Okay, we're gonna get started. Welcome, folks that were at the hockey game. We're all here at Egan High School while you're at the hockey game cheering on the girls. Hopefully they're doing well. They start in about 20 minutes here. We're in Sick Tower. So hopefully you enjoyed the video.
Yeah,
Okay?
we're taking
You
out.
guys want to do a shout out or anything? Bye!
Wait. Shameless.
Okay.
Follow Peter on Twitter.
We're all bathrooms who like to stay in math class.
Okay, so here we go. We're going to start with the unit circle. So everybody wants to have the yellow unit circle worksheet out in front of them. Because what our goal is for today is we're going to just kind of fill out the unit circle. We're going to fill out the degrees around our unit circle, the radians around our unit circle, and the coordinates around our unit circle. I talked a little bit about this yesterday, okay, but this is all brand new to you. You have not seen this before, and you're just starting your journey with trigonometry. So this unit circle is something that we're going to develop this year. We're going to do some work with it this year, and then you're going to continue on with it next year in Algebra 2 and pre-calculus and calculus, and you're going to see this a lot, okay? So today we're just starting the very basics of a unit circle, okay? So up here I have circle measurements. I have degrees, I have radians, we have gradients, degrees, minutes, seconds, and revolutions. Okay, these are all ways that we can measure around a circle. And if you wanted to take some of these kind of side notes, you could even do it on the back of your yellow sheet if you wanted to, or kind of up on the side if you wanted to. The back might be a good spot. But if you notice, I have two of them in green, and those are the two that we're going to focus on. We're used to seeing measurements in degrees. How many degrees is in a full circle? 360. Okay. And radians is something that you've never seen before, but something that you have seen. What's a circumference of a circle? Anybody remember the formula? Pi d. Pi d. I think some of the middle school teachers taught it as a song. Okay?
That's awkward.
So pi times the diameter. What's another way that we could represent the diameter in terms of the radius? 2 times the radius, right? Okay? So 2 pi r is a way that we could represent the circumference of our circle. The unit circle, which is what we're going to focus on today, has a radius of 1. So a full rotation around our circle in what is called radians, and these will make more sense as we continue on here, it's just another way to measure an angle, is 2 pi. Okay? And I just have the other three up here just so you can see there's different ways that we can think about going around our circle. We see degrees the most common. Radians are going to become more familiar to you as you continue on here in math. And then I've never honestly done anything with radians, but it is a way to measure around a circle. And then degrees, minutes, seconds, and revolutions are just rotating. A full revolution is once around your circle. Okay? All right. So what we're going to start with is building a unit circle. And in order to do that, we want to look at some specific rotations around our unit circle. And we're going to start with degrees because that's what we're sort of the most comfortable with. So looking at your unit circle, you want to think about this as a coordinate plane. So here's my x-axis. Here's my y-axis. This would be the origin in the center there, that point 0, 0, right? And so looking at this, I get 4 different quadrants, just like I would if I was just looking at plain old normal geometry. So this would be quadrant 1. And what do I know about x and y in quadrant 1? They're both positives. Quadrant 2, because we typically rotate counterclockwise around. My x values now are negative. My y values are still positive. In quadrant 3, my x values are negative. My y values are negative. And in quadrant 4, my x values are positive and my y values are negative. Okay. So just again, remembering that we've put our unit circle on that coordinate plane. where the center there is the origin at 0, 0, and we'll talk more about the actual points around our unit circle in a second. So the first thing that we're going to go around and do is we're just going to fill in the degrees around our unit circle. So the x-axis right here, so this line right here, okay, we kind of call that the standard position of an angle, and so that's sort of our starting point. And so we're going to label that as 0 degrees. Okay, if I were to rotate all the way around to my unit circle, all the way around here, what would I end up at the same spot here? 360 degrees. So 0 and 360 are said to be coterminal. Coterminal just means that they finish in the same spot. The angle stops at the same location, or it doesn't even start technically with a 0 angle, right? Okay, so let's think about this. If I were to rotate then halfway around my circle, where would I be at on the other side of my x-axis? 180. Okay. And now we could think of those in increments of halves as well. If they're split into 4 quadrants too, another way to think about it is, what's 360 divided by 4? 90. So up here on this side of my y-axis, I'm at 90 degrees. Here I'm at 180. Another 90 degrees would bring me to 270. Okay. So we're going to look at some special angles around our unit circle. So the first ones we're going to look at are this middle line right here, this angle. It's exactly halfway between 0 and 90. So what would that angle be? 45 degrees. So we're going to work our way around our unit circle in increments of 45. So we started at 0. Here's 45. Then we're at 90. So what would this angle right here be? 135. Okay, then we're at 180. That's right. Another 45 degrees right here would put me at 225. 270, that makes sense. 225 plus 45 is 270. And then another 45 degrees to right here would bring me to 315. Okay, and then another 45 brings me back to 360. Okay. So it's a little hard if you're just looking at this to figure out what the increments are for the next one, but the last week or so we've been studying 45, 45, 90 triangles, and what other kind of triangles? 30, 60, 90. Remember I said that their importance would become even more important as we started looking at the unit circle? Okay, so what do you suppose this first increment is right here? 30 degrees. So now we're going to work around our unit circle in increments of 30 degrees. So we go to 30, then we're at 60. Okay, then we're at 90. So then this next one right here would be 120, 150, 180, 210, 240. So we're just working around increments of 30, 270, 300, and 330. These are special angles that we want to identify on our unit circle, and so that's why I was saying, you just looking at that, you might not have known that that was 30, so I'm telling you that that's 30, and so then we're able to work our way around, okay? So here are all of the angles that we're going to focus on our unit circle. 0, 30, 45, 60, all the way around, okay? Knowing this now, if I gave you a blank one, could you fill out all the angles? Yeah, it's pretty easy, right? Okay. So there's one way that we can measure the angles around our circle. Now one thing you need to know about this, again, is that our unit circle has a radius of 1 and a complete rotation is 360 degrees. Now normally we rotate around counterclockwise, that's a positive angle, but you can also rotate around it clockwise and you get a negative angle. Okay. So this might be something I'd put on the back of my yellow sheet or off on the side somewhere. So, and just as a reminder as well, a radius of a circle, right, is from the center to any point on the circle. So my radius being 1, we're starting here at the center, out to any point is 1, a unit of 1. And we're not specifying what unit it is. We're not looking at it like it's 1 inch or 1 foot or it doesn't matter. We're just saying it's represented as 1 unit. Okay. So if I go back here, a negative 30-degree angle would be the same thing as a 330-degree angle, right? Or a negative 120-degree angle would be the same as a positive 240-degree angle. Or you can think of it as well too, a negative 240 would be the same as a positive 120, depending upon how you rotate. Those are called coterminal angles. So any angle that ends in the same spot, so like I said about 0 and 360, the same is true about any angle that finishes at the same location on your unit circle is said to be coterminal. And we'll talk more about those in just a second. Okay? Okay. So radians, this is something that's a little bit more new to you, but radians are another way that we can measure an angle on our unit circle. Okay? And like I said before, because our radius of our unit circle is 1, one complete rotation around our unit circle in radians is 2 pi. Okay. One complete rotation is 2 pi. And really from all of this, that's sort of what you need to take away from it right now, is the fact that one complete rotation is 2 pi. Okay. So what we're going to do now is we're going to go back to our unit circle and we're going to fill in all the radians. So if you even wanted to right now, if you have like a different color pen, so it might make it easier, it might make it kind of nice to have different colors going on your unit circle. I'll show you once we get all done filling this out. You can even find ones like online where they have all the different coordinates and everything in different colors, and it's kind of nice to look at like that. Okay? Okay, so we're going to go back to our unit circle here. And now we're going to fill in the radians. Okay, so we're still starting at 0, so a 0-degree angle is 0 radians. And what did we say one complete rotation was in radians? 2 pi, right? So 0 and 2 pi are the same. If one complete rotation all the way around is 2 pi, what would a half of a rotation over here at 180 be? 1 pi, or we could just say pi, right? Okay, that's going to become important in just a second because do we like these radian things at all yet? No, what are we more comfortable in? Degrees. So on my unit circle, I might circle this fact. What is pi equivalent to? 180 degrees. That will help us out here in just a second. Okay, so if this is pi over here, and this is halfway to pi, what is 90 degrees the same as in radians? Pi halves, right? So these increments of each of the quadrants are in pi halves. So this is like 0 pi halves, 1 pi half, 2 pi halves. What's 2 pi halves reduced to? 1 pi, which is right. And so then 270 would be 3 pi halves. And then if I kept going, I'd be at 4 pi halves, and 4 pi halves would reduce to 2 pi. So we're back around to where we started. Okay? So if this at 90 degrees is pi halves and 45 degrees is half of that, what are my increments of 45 degrees going to be in? So it's a half of a half. Fourths, right? So 45 degrees is pi fourths. So we're going to do the same thing and think of it in terms of, so here's 1/4 pi, 2/4 pi, which reduces to 1/2 pi, or pi over 2. Okay? 3/4 pi, and we always write it as 3 pi over 4. So it's the same thing as 3/4 times pi, but we just write it as 3 pi over 4 is how you're going to see it. 4/4 pi, or 4 pi over 4, and that reduces to just pi. Now we're at 5 pi fourths, which we can't reduce. 6 pi fourths, which is reduced to 3 pi over 2, so that makes sense. And then 7 pi fourths, which we can't reduce, so we leave it like that. And then we're all the way back around at 8 pi fourths, which is 2 pi. Okay. So now looking at our 90 again, if this is pi halves at 90 degrees, and we want to start doing the increments of 30 degrees, it's a third of 90. So what's a third of a half? 1/6. A third of a half is 1/6. So each of my 30 degrees as I move along my unit circle are going to be increments of pi 6. So 30 degrees starts us with 1 pi 6. Then at 60 degrees we're going to be at 2 pi 6, but what would that reduce to? Pi over 3. Okay. Then we're at 3 pi 6, which is pi over 2. And so then here we're at 4 pi 6, which would reduce to 2 pi over 3. Okay. 5 pi 6, which I can't reduce. So 5 pi 6 is the same as 150 degrees. And then 6 pi 6 would reduce to just pi, so that's right. 7 pi 6 at 210 here, can't reduce that. 8 pi 6 would reduce to 4 pi over 3. Nine pi 6 reduces to 3 pi over 2. 10 pi 6, this one's a little weird to reduce, but that would reduce to 5 pi thirds. And then 11 pi 6. And then we're back at 12 pi 6, which is the same as 2 pi. Okay. We would never make you come up with all the radians or all the degrees around a unit circle, but if you took the time and thought it through, could you do it? Yeah. Okay, you could. Okay, so like I said, for the most part, we're way more comfortable with degrees. You have to know radians because radians will come up a lot. But for this class, you can simply take your radians always and convert them to degrees. Because it's just a lot more intuitive for us to look, oh, 90 degrees, that's easy. Pi halves doesn't sound as easy to find on a unit circle, but we all know where 90 degrees would be located. Okay? So what we're going to take a look at now is how we convert from radians to degrees. Do not think of it like this formula. I have the formula right here. But more so just think of it back to our unit circle and what did we say that pi is equivalent to? 180 degrees. So all that you're going to do is anywhere you see pi, replace it with 180 degrees. And a problem like this, I could plug it in my calculator and do 11 times 180 and then divide by 6. Or do we all know what 180 divided by 6 would be? 30, and what's 30 times 11? 330. So 11 pi over 6 is equivalent to 330 degrees. Does that hold true on your unit circle? Look on your unit circle. Is 330 the same as 11 pi over 6? Yep. Yeah. So you see how, as long as you know this conversion, you don't have to deal with radians that much. If you have a problem with dealing with radians, replace pi with 180 and switch it to degrees, which is what you're more comfortable with. Okay? So this one right here, same thing. Replace pi with 180. And 180 divided by 3 would give me 60 degrees. Okay, 7 pi over 6. Replace pi with 180. And again, on this one, you could plug in 7 times 180 and divide by 6. Or you can just think about it, 180 divided by 6 is 30. 30 times 7 is 210 degrees. Okay. Questions? What do we think so far? You got it?
Yeah.
You gotta just follow it right now for what it's worth, and not try and like leap ahead and understand where this is going. Understand it for the moment right now. Like, do you understand how we got all those degrees? Do you understand how we got all those radians? And do you understand that if you had given something in radians, you just simply replace pi with 180, and you can convert it to degrees.
But like,
See how?
why would they create two separate forms? Why wouldn't they just create one?
You'll see that's the bigger picture idea. You'll understand where radians become very important and where we can use degrees to measure angles. So you have to know and be able to do both. Yep. And that's a way bigger question than I could answer even in 10 class periods maybe. Okay? That's like a whole course. Okay, so in order to fill out our unit circle, we're going to talk about something called a reference angle. So I would definitely put a few notes on the back of my sheet, and you can actually just put what I'm going to put off on the side here. So what is a reference angle? I'm going to give you 3 kind of key points that we have to remember for a reference angle. Okay? So the first thing that's going to always be true about a reference angle is it always has to fall between 0 and 90 degrees. Okay? So a reference angle cannot be greater than 90 degrees or less than 0. You can't have a negative. So that's the second piece to it. It's always a positive angle. Okay. And what the heck is it? Well, a reference angle is the angle that gets us back to the x-axis. Okay, so if you're looking at the diagram that's up here on the board, the blue angle is the actual angle. That's theta that we're looking at. And so then this shaded area here in beige, that's the reference angle. From this angle, it's the angle back to the x-axis right here.
Is it like a complementary angle?
Not necessarily, because we're going to look at this when we rotate all the way around our circle. Okay? Okay? So here's some examples. This one says, first draw a 300-degree angle, and then identify the reference angle is what we're going to do. Okay? So if I draw a 300-degree angle, I'm starting here. I always start here. I'm rotating 90, 180, 270. 300 would be about right here. Okay? This right here in red, that's my reference angle. And if I'm at 300, how many more degrees do I have to rotate to get back to the x-axis? So my reference angle is 60 degrees. Okay? Negative 150-degree angle. I'm still starting here. I've rotated negative 90, and another 60 would get me at negative 150. Remember that that's coterminal, and that would be the exact same thing as rotating how many degrees in a positive direction? 210, okay? And so my reference angle is, again, the angle back to the x-axis. Why do I know that it has to be this tiny angle right here and not this big angle over here? Because both of them would get me back to the x-axis. It has to be less than 90 degrees. And we don't think about this at all in terms of rotating. So even in this quadrant, we still refer to our reference angle as just the positive angle. So it's just essentially the number of degrees back to the x-axis. So this would be a reference angle right here of 30 degrees. Okay, it would take me 30 degrees to get up to the x-axis right there. Okay, 900-degree angle. Well, if one complete rotation is 360 degrees, I'm going to start out rotating here. Once around, I've gone 360. If I go around again, I've gone 720. And I'd have to keep going all the way over here 180 degrees to get there. What's my reference angle if it's on the x-axis? 0. So it has to be between 0 and 90. And so if it falls on the x-axis, your reference angle is 0 degrees. If it falls on the y-axis, your reference angle would be 90 degrees. Okay. Okay, so here's just some more diagrams showing you pictures of reference angles. So here's a 150-degree angle. The beige part right here, my reference angle is 30 degrees. Negative 130, my reference angle is 50 degrees back to the x-axis. 280 degrees, it's a big reference angle. It's an 80-degree reference angle. Okay, but it's just always the angle back to the x-axis. And it's important to remember that it's back to the x-axis, not the y-axis. Okay. So we're going to draw a few. If I were to draw a 330-degree angle, around here, that's going to be about right here. What's my reference angle for this one? 30 degrees. Okay, so there's part A. Part B says to draw a 135 degree angle. So 135 would be about right here. What's my reference angle for this one? Well, all the way to here would be 180, and I'm at 135. How much further do I have to rotate? 45 degrees. Okay. Part C, this one's going to be a little bit interesting. Actually, I'm going to put C right here, so it's right next to it. So C, we're down at 225, which would be about right here. What's the reference angle on that one? It's also 45. So do we see how this angle right here of 135 has the same reference angle as an angle that's 225? Okay, and this last one is in what right now? Radians. Do we like radians? No. So can we replace pi with 180? It would be 120, right? 180 divided by 3 is 60. 60 times 2 is 120 degrees. Okay, so if I draw a 120 degree angle, that's about right here. And what's my reference angle? 60 degrees. Okay. Now, one thing that's helpful to remember with reference angles are bow ties. Bow ties. Miss Lee was telling me today at lunch that when she taught this in years past, she would have people bring bow ties with them to school when she taught this lesson, and she'd wear a bow tie too. Okay? But where these are helpful is, okay, let's just say we're looking at angles around our unit circle. What happens if I draw a nice, perfectly symmetrical bow tie? What are the reference angles for all of these angles? Well, not necessarily 45. We don't know what they are, but are they all the same? Yes. So the reference angle here is the same as here, is the same as here, is the same as here. That key point is going to help us now to fill out our unit circle and to find the coordinates around our unit circle. Okay? So what we're going to do is we're going to start filling out finding these points on our unit circle. So like here's a point, and we're going to do that for each of these special degrees or radians that we filled out on our unit circle. Okay? Now this is the origin right here. This is 0, 0. And if my radius of my unit circle is 1, where am I at here at 0 or 360? What's my x coordinate? 1. What's my y coordinate? 0, right? Have I gone up any distance in the y direction? So, okay, again, remember that the radius of our unit circle is 1. And so if this is at the origin right here, and I'm going out to a point on my circle directly across there, this has to be the point 1, because that x is telling me how far to go in the x direction, so I'm going over 1. That's my radius. But I haven't gone up or down at all. So my y coordinate is 0. So just think about plotting a point on a coordinate plane, and you've got this circle drawn whose radius is 1, and the center is at the origin of your coordinate plane. Okay, so then what would my coordinate be at 90 degrees? 0, 1. Okay. Over here at 180, I'm now in the negative direction, so -1, 0. And at 270, I'm at 0, -1. Okay? Those are the really easy points to fill out around our unit circle. Okay? So you want to be filling these coordinates out around your unit circle with me as we're going along here. Okay? Okay, are we ready for special right triangles? Go back? Okay. Just those 4 coordinates you're filling out. Yeah, people that are watching this at home could hit pause, right? If we're going too fast for you at home, you can hit pause right now.
Wait, so are you like recording your
I am right now. We're on, it's recording. So they can hear my voice and then they can see what's going on the screen.
Can I hear us? Hello?
Okay. So what we're going to do now is we're going to look at 30-degree angles. So we're going to focus mostly on quadrant 1 because you guys are actually next Thursday. You're going to take the first part of the Chapter 7 test is on the unit circle, and you're not going to have a unit circle in front of you. So you're going to have to be able to find some of the stuff without your unit circle in front of you. You really, if you understand 45, 45, 90 triangles, 30, 60, 90 triangles, and you understand reference angles, you can do all of this without the unit circle in front of you. But there's more thought involved, okay? So that's why that's why we're devoting 2 days with no homework to just simply taking notes on this. So you guys really sort of digest all of this, okay? So here in quadrant 1, we're going to take a look right here at our 30-degree angles. Now imagine if I were to draw a right triangle there with my 30-degree angle. So here's my right triangle. What kind of a triangle did I just create if this is 30 degrees and I made this a right angle of 30, 60, 90? And looking at this, from here to here represents the x-coordinate of where I'm located at this point, right? That's how far out I've gone in the x direction. What does this side of my triangle from here to here represent? Your y-coordinate. Okay? So just so it's a little easier to see, we're going to imagine taking this triangle right here and we're pulling it over here. Okay? What's the radius of my unit circle? 1. And what part of my triangle is the radius? The hypotenuse, right? So look right here. Here's my radius. And on my right triangle, that's the hypotenuse. And the radius of the unit circle is 1. Okay. Now we got to remember that special right triangle stuff. How do I go from the hypotenuse to the short leg? I divide by 2. Divide by 2. So if my hypotenuse is 1, my short leg is 1/2. Right? 1 divided by 2 would give me a short leg of 1/2. And then how do I go from my short leg to my long leg? Multiply by radical 3. And so if my short leg is 1/2 and I multiply by radical 3, it's 1/2 radical 3. We can just write that as radical 3 over 2. Okay. So we're going to transfer that now. If my radius is 1, this represents the x-coordinate. This represents the y-coordinate on my unit circle. So for a 30-degree reference angle, my x-coordinate is radical 3 over 2, and my y-coordinate is 1/2. Now take a look at this. If my y-coordinate is 1/2, if this is 1 from here to here, does this seem like it's about halfway right here? Yeah. If you were to plug into your calculator radical 3 over 2, that's approximately 0.866, okay? If this is 1, does this seem like 0.866? Yeah. So there's that coordinate on our unit circle. Jared?
How did you get 1 for the hypotenuse?
Because it's the radius of my circle. Because this is the center of my circle. And the radius of our unit circle is 1. And so the hypotenuse goes from the center out to a point on my circle.
So the
Alex?
hypotenuse will always be 1.
1 for all of these, okay? So now we're going to use that bow tie and reference angle idea. So in quadrant 1, my x and my y coordinate for 30-degree reference angles are radical 3 over 2 and 1/2. All 4 of these angles have a reference angle of 30 degrees, right? 150, reference angle right here is 30 degrees. 210, the reference angle is 30 degrees. 330, the reference angle is 30 degrees. So what do you suppose the coordinates are for all of those points? The same, except for we have to remember what quadrants we're located in and whether or not x or y is positive or negative. So they're all going to be radical 3 over 2 and 1/2. But what's true about x and y in quadrant 2? x is negative, so it's going to be negative radical 3 over 2, positive 1/2. Okay, quadrant 3, both are negative, so negative radical 3 over 2, negative 1/2. And quadrant 4, x is positive, so positive radical 3 over 2, negative 1/2. Do we see the bow tie? We see the bow tie where they all have the same reference angle? So you see how you don't have to memorize things if you understand the reference angles, and you know that the radius is 1 and your hypotenuse of that triangle is 1, you could always figure out your way to the radical 3 over 2 and 1/2, and then just transfer that to the other reference angles, okay? So all of these have a reference angle of 30 degrees. Okay, so you want to fill out those coordinates so around your unit circle. Are we at least following me on what we're doing on this so far? Okay. Okay, so now we're going to look at 60. We're going to look at 60. So let's think about this one. So our hypotenuse is still 1, right? All that's happening is what has flip-flopped. My short leg is now right here, so it's 1/2, and my long leg is now right here. It's radical 3 over 2. So again, remember I can draw, it's the same right triangle here inside here. Okay, and so the two coordinates have just flip-flopped. Rather than x being radical 3 over 2 and y being 1/2, now x is 1/2 and y is radical 3 over 2. Okay. And again, does this kind of make sense if we're looking at this? Does this seem like about halfway to right there? It's not a perfectly straight line, but is that about halfway? Yeah? And then if I'm looking at this distance up to right here, does that seem like about 0.866 if that's 1? You bet. Okay. Now before I go to the next slide, who could tell me what the x coordinate would be for a 120 degree angle? Negative 1/2, right? Because are we going to have the exact same thing occur now? All of the angles that have a reference angle of 60 degrees, so 60, 120, 240, and 300, are all going to have x and y coordinates of 1/2 for x and radical 3 over 2 for y, just the variance in the positive or negatives depending upon what quadrant you're in. So it's again, it's 1/2 radical 3 over 2, and then in quadrant 2, x is negative, y is positive. In quadrant 3, they're both negative. And in quadrant 4, x is positive, y is negative. So those all have a reference angle of 60 degrees. Okay, what do we have left? Steven?
I was asking, how do you find those coordinates? Like,
Now say that again.
how do you find the coordinates for those?
For this one again?
Yeah.
Okay, so it's the, here, let's go back one then. It's the same idea as what we did on the last one. So if my hypotenuse is 1, to go from the hypotenuse to the short leg, I divide by 2. So the hypotenuse on all of these is my radius of my circle, and it's 1. And so to go from hypotenuse to short, I divide by 2. And this right here is my short leg, so 1 divided by 2 is 1/2. And then to go from the short leg of my 30, 60, 90 triangle to the long leg, I multiply by radical 3. And so 1/2 times radical 3 would give me the long leg, which is radical 3 over 2.
How do you figure out that this half angle is 30 degrees to not 60?
Because we're looking at this, we're looking at it on our unit circle right here. We're specifically taking this triangle right here, where we know that we're looking at this being the 60-degree angle. This is 60 right here. And so if I'm drawing this perpendicular, this has to be 30. Okay? Okay, so last but not least, we have 45. Okay? And so that's this triangle right here. We're going to find the x and y coordinates for 45-degree reference angles. So my hypotenuse right here still represents the radius, and the radius is 1. How do I go from the hypotenuse to a leg in a 45, 45, 90? What do I have to divide by? Divide by radical 2. So if I take 1 divided by radical 2, I can't leave it like that, because we don't ever leave a radical in the denominator. But what could I multiply to get rid of the radical in it? Radical 2 over radical 2. And so it would be radical 2 over 2. And what's nice about 45, 45, 90 is both legs are radical 2 over 2. Yeah, so the x and the y coordinate is the same. Doesn't that seem to make sense? Because shouldn't that point be kind of the exact middle, or it's halfway between 0 and 90? So both your x and your y coordinate are radical 2 over 2. So again, all of those increments of 45 degrees, okay, or reference angles of 45 degrees, are going to have x and y coordinates of radical 2 over 2, just the variance in the positive or negative. So all of these are reference angles of 45 degrees. And so quadrant 1, we get the radical 2 over 2. Both x and y are positive. In quadrant 2, x is negative, y is positive. Quadrant 3, they're both negatives. And quadrant 4, x is positive, y is negative. Okay. So if you're looking at your unit circle right now, you should realize you have a lot going on there, yes? So here's one where it's got everything filled in. Doesn't have the radians, I guess, though. That's the only thing it doesn't have on there. But there's all my coordinates around the unit circle. That was our goal for today, was to simply fill in the coordinates and the degrees and the radians. Okay? Any questions on that? Tomorrow what we're going to do is we're going to start looking and filling back in those sine, cosine, and tangent values and